Okay, we're going to continue looking at uh, data plots, specifically those ones we looked at last time, those data distributions of histograms and box plots. And we're going to describe them, learn some vocabulary that goes with them, and learn how to compare multiple data sets to figure out, well, what can we conclude based off of two data sets? Can we conclude, if the means are higher, which one has more variability? So we'll talk about that as we go through our lesson today. So first and foremost, let's just get some information down on shape, center, spread. Some big terms that we want to keep in mind. So some vocabulary you want to highlight and understand as we go through here. So as we talk about shape and spread, shape, well, shape of the graph. Spread, how far apart it is. So talk about modes most often. It can be a uniform, where everything is pretty much straight across the board. There's no obvious mode. Unimodal, uni meaning one, so one main mode. Bimodal, we've got two main peaks. Multimodal, multiple places where the data is relatively higher. Skewed distribution, when data is to one side, leaving the other with a tail. So data is skewed to the side of the tail. So let's say we've got some data, and it looks like this. We'd say it's skewed right because it's got a tail off to the right. Outliers, values that stand away from body of distribution. Typically we said it's 1.5 times the interquartile range is a good rule of thumb. Normal distribution, the curve is unimodal and symmetric. Kind of look like that. One mode, it's all symmetric. Variability, how close are they together? Low variability, they're very close together. They're spread apart. High variability. And then we talk about center. See if we can find one value that can describe the data set. So normal distributions are easy. It's right there. If it's not normal, determine if there's a center value that best describes the data. So, see if there's a value that can best describe where the center of everything is, as we kind of talk about the mean, median, or mode. So bimodal, multimodal data may not have a center. For instance, if we have something like, these two peaks, it's hard to tell where the center is. Or, we've got a histogram, and all of a sudden we've got another mode up here. So it's hard to tell where, where the center would be in that particular data set. So we'll take a look at what we can, but describe it as best we can in order for interpreting. So let's take a look at the texting by the numbers lesson that we had last time. And let's describe the shape, center, and spread. So you're going to take the time to do that. First of all, describe the distribution of the histogram that we looked at last time. Secondly, describe the box plot of just Rachel's text, or her friend's text. So how would you describe those? So look back at your vocabulary. How would you describe the shape? What kind of mode do we have? Is there a skew? Are there any outliers? A normal distribution. What kind of variability is there? Where is the center? So take the time to do that and restart the video when you're done, and I'll share my thoughts and we can compare. So as we look at our histogram, we can clearly see that it's bimodal. Two places where the graph spikes. It appears to be a skewed right. Numbers kind of decrease as we go left to right. It's got some high variability from 0 all the way to 280, with a possible outlier here at 260 to 280. And we don't really have a center since it's bimodal. Our box and whisker plot is unimodal. It's a normal distribution with about half to the right, half to the left. Our center is clearly right here at about 140, 145. It's got low variability. Numbers range from about 120 to 175. And we've got multiple outliers at the beginning and at the end. So those are just a few examples. You're going to take a look at the next few data distributions. You want to describe each of these 6 different classes, and then we're going to compare data distributions between the different groups as we go through there. So pause the video, make your own notes, and then when you're ready to see my notes, we can compare when you're ready to restart. So pause the video, restart when you're ready. Okay, so let's take a look at what you found, and I'll share what I thought. Smith's class seems unimodal. We got one main mode right here, and it's skewed to the right. Lemon's class is pretty uniform. They're all about the same as we go through it. This one has pretty high variability. This one's a little bit lower, from 70 to about 90. Croft is unimodal. Looks about normal distribution. Center's at about 80, and there's an outlier over here at about 41. Adams, normal, unimodal. Well, Croft, to be honest, we really can't tell if it's unimodal or not, because we don't have the histogram value. So I'm just going to scratch it off because I don't think I can really tell. This one's about normal, unimodal, center at about 80 to 85. Hurley, same thing. I said unimodal, but it's really hard to see on the box and whisker. It's about normal, center here at about 82. Variability is a little bit higher. And Jones, unimodal, skewed to the left, and we've got an outlier over here at about 40 to 45. So as I mentioned, it's easy to tell the modes on histograms on our box and whisker. We can tell our variability on both of them and those distributions as we take a look. Next, we're supposed to compare Smith and Adam. Just looking at it, we can see that Smith is skewed to the right while Adam's more normal. They both seem to be about unimodal. The other thing is I thought their variability is pretty similar, 60s to 100s. And other than that, Adam's center is a little bit higher at about 80 to 85, whereas the center here, it's hard to tell exactly where the center is, but it's probably closer to 70, 75 since our modes are over here. Smith, the lemon. Smith has a mode. Lemon's is uniform. Variability for lemon is smaller than Smith. The center for lemon would be higher than Smith's class. Croft and Hurley. Let's see. So as we take a look at it, the center for Croft's is lower than Hurley's. The middle values are a little further apart in Hurley's, and Hurley's range is a little greater. Well, actually, it's about the same, isn't it? About 60 to 100. But Croft has this one outlier out here. The other thing with those, they seem to be about normal distributions. A little bit harder to tell because we don't know the frequencies, though. And then if we compare Adams, Hurley, and Jones, we've got two histograms and a box and whisker plot. I would say that Jones is skewed to the left, while Adams is more normal, and Hurley's appears like it might be more normal. The whisker, we can kind of tell, maybe it's a little more skewed to the left with Hurley's with a longer whisker. And then Jones, we might say, has smaller variability, 60 to 100. Actually, they're all about 60 to 100. So the variability is the same as well, but the center might be a little higher with Jones as compared to, since we have our mode pretty high here for Jones, center here is about 85 and about a little under 85. So we can compare where most of the majority of the numbers or the centers are with these and compare them pretty well as we take a look. So that's how we compare the different data distributions. Like I said, it's easier when we have the same type of distribution, but we're looking to describe the shape, the center, the spread, and kind of get a better idea of what we're looking at with the data. Is there a mode? Do most of the values lie to the left or the right? Are they skewed? Are there outliers that increase the variability? Is it more of a normal distribution? There's few, then we get more in the middle, and then less as we go down. So those are the things we want to look for as we describe data. Your work that you can do in class is reviewing some work with sequences. See if you can figure out the pattern and explain how you know. And then going back to drawing some histograms and frequency tables and making that, and then describing that using what we learned about modes, skew, outliers, normal, center, spread. And then finishing up with some work on percents. Hopefully you remember how to do that. If not, you'll have to review that. So that's all we have in this lesson. We'll see you next time.